Good morning, everyone. My name is Giovanni Cautillo, and I'm the president for the Ontario General Contractors Association. Welcome, one and all, to our OGCA webinar series. This is yet another installment of value-added learning and interactive. We'll do so. It's a lot better in person, but under the circumstances, we'll have to do this virtually. The topic today is one that is of great interest to everybody in the ICI sector in construction, simply because we have a plethora of individuals that have registered for the webinar. So obviously it is something that everyone would like to know about. I think the title is short and sweet, yet to the point: mass timber issues and opportunities. And our panelists today, we are joined by Patrick Chouinard, which is the VP of Market Strategy and Corporate Communications at Element 5, and Matt Bolen, which is the Principal Architect at Edge Architects. Incidentally, today is Matt's birthday, and there will be a quiz afterward for whomever can come in as to what his age is. We'll give out a prize at the end of this. Speaking about the structure of the webinar, anyone who has any questions, please utilize the question and answer function. We will answer questions at the end, simply because a lot of them will be addressed throughout the presentation. I know for a fact that Patrick and Matt have a very intense and very interactive kind of presentation. Speaking of presentations and our panelists, I'm going to pass it over to Patrick to start us off. Patrick, good morning, sir.
Good morning. Thank you very much for the opportunity to present, and thank you very much for everyone who's decided to join us today. So what is mass timber? Mass timber building types fall into three broad categories. The first is post and beam, where glulam is used for columns and beams, and then heavy timber panels to form the floor structure to create the skeletal structure for the entire building. The second mass timber building type is CLT panels, and that is CLT panels that are used both horizontally and vertically to form both the floor structure, the exterior walls, some of the interior walls, with very little use of glulam. And then the third is a hybrid type, much like what you see here, which is a steel building that uses CLT for floor slabs. Mass timber elements are varied, and there are a number of elements available in the marketplace today. So CLT, these stands for cross-laminated timber panels. These are massive wooden panels. In our case, we make one that's 11.5 feet wide, 53 feet in length, and about 15 inches in thickness. They are considered an environmentally friendly alternative to concrete, and they're structural panels. Then there's glulam, which is used for columns and beams, followed by NLT, which is nailed laminated timber panels. And these are panels that are made up of dimensional materials, 2x4s, 6, 8, 10, and 12s that are nailed together to create panels. Then there's DLT, which is doweled laminated timber, which is the same as NLT, but instead of nails, they use dowels to fasten the dimensional materials together. Then there's MPP, which is mass plywood panels. This is plywood panels on steroids. The same as plywood, except much thicker and much larger. Then there's clips, which stands for cross-laminated insulated panels. These are prefabricated panels that come prefabricated from the factory, and they're used to quickly enclose the outside of a building. Then there are box panels, and these are CLT panels essentially, but they're hollow in the inside. They allow us to span greater distances than a typical solid CLT panel, but cost effectively against concrete and steel. And then we have rib panels, which are just like a box panel, except there's CLT just on the upper surface rather, and exposing the joists below. The connections in mass timber buildings are really quite simple. It's made up of engineered brackets, plates, hooks, concealed junctions, screws, dowels, and adhesives. So the buildings go together very quickly. Mass timber in Ontario. We're in the midst of a revolution in the construction industry that began in Europe about 35 years ago, landed on the shores of British Columbia, and now has made its way all the way across Canada as well into the United States. It's characterized by buildings that are being prefabricated in high-tech manufacturing facilities and shipped to site where they are assembled rather than constructed in the traditional sense. This building is the student residence at the University of British Columbia, and it's reflective of the future of mass timber. It sits on a concrete podium. On top of that sit the glue lamp columns that you see here on the left-hand side. And above that are the CLT panels for floor and roof structure. What's also interesting about this building is the use of these prefabricated panels on the outside, very much like our clips panels, to quickly enclose the outside of the building. This building, standing at 18 stories, was rendered completely weathertight in only 9.5 weeks. Mass timber is happening in Ontario in a big way, and this is a selection of some of the larger projects that are currently under construction, or either recently completed or currently under construction in Ontario. Element 5 was founded in 2015, and we've done approximately 80 projects to date. And I've listed all of these here just to give you a sense as to where mass timber is used, in what industry sector and in what building typology. So we have a fire hall here, top left-hand corner. This is a 3-story hybrid office building. It's a steel building using NLT roof panels. The next one is an extension to a library at Wilfrid Laurier University. The next one is an Aboriginal healthcare center in London. Then we have a boaters pavilion in Aurelia. Bottom left-hand corner, an office building in Quebec. We've done quite a number of single-family homes and cottages, and then everything from there up to the next project, which is our largest project. It's an 80,000 square foot office building for the Toronto Regional Conservation Authority. And recently we've been doing quite a lot in affordable housing. So the first one that you see second from the right on the bottom is an affordable housing project for the YWCA in Kitchener, which Matt will talk about. The next one is a bit of a hybrid. It's also affordable housing. It uses CLT for the floor slab, but it uses light wood frame interior and exterior walls. Lots of new projects that were under contract to supply in 2023 and beyond. So here we have, top left-hand corner, a daycare center in St. Thomas. This is a veterinarian clinic in Michigan. The next one is a golf club house, also in Michigan. We have a mixed-use building in Hamilton, a student residence for the University of Toronto. Then we have an Aboriginal school in Northern Ontario, a photo museum in Cincinnati, 2 more mid-rise multi-use residential buildings, and then the last one here is we just got a contract for this little portico on the outside of a university building in the United States. So why mass timber? The building you see here is called Ascent. It's the tallest mass timber structure in the world. It's in Milwaukee. It's a 25-story building. It has 17 stories of post and beam with CLT floor slabs above 8 stories of concrete. This little graphic you see here, I've taken right off the developer's website. And these are the reasons why they used mass timber and the result of actually building in this way. So the first reason is they used mass timber because it's a renewable resource. In this case, there was 90% less traffic on the job site. It required 75% fewer on-site workers, and it was built in 25% less time. From the environmental perspective, there's a major push to build in mass timber for environmental reasons. The concrete and steel industries are responsible for somewhere between 12 and 14% of the carbon dioxide in the world today. World population is growing from 7 to 9 billion over the next 35 years, and we know we cannot continue to build the way we've been building for the last 100 years. When we're building with wood, what we're doing is we're leveraging our forest's natural ability to absorb carbon. And so when building with wood, what we have done is found a systematic way of not only removing carbon dioxide from the atmosphere, but storing it in the form of these beautiful buildings. There's also an incentive to use mass timber for the aesthetic. Many of these buildings are considered quite lovely on the inside. The upper row are the interior of residential spaces. The bottom row are the interior of commercial spaces. And then there are the health and wellness benefits. Many biophilic research studies have been done that shows that there are health benefits associated with living and working and educating our children in environments where the occupants are exposed to natural elements. And as humans, we are just naturally connected to these types of spaces. We were asked to address the issues around mass timber, and the first question that always comes up is how much. So I thought I'd address that right away. A number of studies have been done that look at cost comparisons between mass timber, steel, and concrete. This is one particular study that was completed in July of 2021 that looked not only at the cost differences between mass timber, steel, and concrete, it also looked at the global warming potential, or essentially the impact on the environment. And I say this is true pretty much of every study. The results are always about the same. Essentially what they're saying is mass timber costs the same as concrete and steel, but if you can build in wood for the same price, but you have less negative impact on the environment, why not build in mass timber? So with that, I'm going to turn it over to Matt Boland, with whom Element 5 has worked on quite a number of projects together. So Matt.
Thanks, Patrick. So yeah, very grateful to be here. Not so grateful about the birthday shout out, but I guess I'll carry on. This for us, and I think picking up where Patrick's left off here, mass timber for myself professionally has been an interest of mine for about 20 years. So I was, 15 years after the European invention or proliferation over there, definitely has been on my radar. And then specifically Edge Architects and our group for the last 7 years has been really in tune and focused on mass timber and how we can design with it and actually get it executed on built construction projects. So today, what I want to go through, and again, in sort of a quick way, is our firm's pursuit of executing mass timber. Next, I want to talk about a rapid housing response. And I know that this group specifically, it has more of an ICI focus, but I think, understanding the marketplace right now and the dramatic need for housing, that's obviously what's pushing a lot of the construction industry generally. And that's what we're seeing, even though our work is broad and covers a pretty broad range across, all different sectors. That the housing and a rapid housing response was for us ended up being our ticket to getting and realizing mass timber. Next, within that, I'm going to go to that first project that was part of that rapid housing response, which was the affordable housing project for YWCA that Patrick mentioned. And finally, just talk about some future directions for us and the industry as we see. So what I want to start out with is, again, keying in on some of the projects that we worked on where we made our attempt to try and incorporate mass timber, where we thought we had a client group and an overall building team that was interested in the innovation and interested in trying to analyze and assess what could best be used to meet the needs of the project. So these represent 3 in our firm's history and portfolio. And I'm just going to cover these off relatively quickly. Sorry, Patrick, can we go back one? The first was a mid-rise building, infill building. And as a lot of us know, with that missing middle type of typology, understanding the most efficient way to build it is something that's really challenging. So we went through that exercise. Mass timber was one of the final candidates that we chose as our structure for that, but ultimately, due to market and supply back in 2017, we weren't quite there in terms of the client's comfort, and also ended up getting a pricing on a hybrid Hambro style concrete and steel system that worked. The next project, the glove box, was started out as actually a smaller site, and we had this idea for reinterpreting, using mass timber to reinterpret brick and beam office in a contemporary way with all the efficiencies of the Class A office demands that we had. Instead, the project scale and scope grew, which was a good thing ultimately, incorporated a heritage building and just the gymnastics that needed to be done and the appropriateness of using mass timber, given some of the reinforcement that had to be done on the existing heritage structure. It just, again, made more sense to go cast in place at that time on that project. Then we had this wooden project, which was our first introduction to Element 5, who came on for it as our design assist trade, and really helped us with a lot of the innovative design and research and development on this project. We actually got funding through NRCan through one of their programs, their green construction through wood, to actually do all sorts of testing that could help fill in a lot of the gaps and missing information in the marketplace around acoustic and vibration and strength, and just optimizing structure. So this one we thought, well, this is going to be a slam dunk. And as we go to the next slide, we worked through that. We had a really good strategy, and then as maybe some of us know, and our strategy here, as you can see, we actually utilized Element 5's Quebec, Ripon, Quebec's facility for building full-scale mock-ups, testing both qualitatively and quantitatively. We're feeling very good. We're scheduled to submit and make our permit applications in the spring of 2020. And as some of us may remember, that was also coincided with the time when a lot of us decided to move to a work from home model. I can't remember why that was again. Maybe it's just the post-traumatic stress of it all, having 3 kids at home. But for that reason, obviously, market demand on office at the time dried up a little bit. So bringing that type of a spec office building to market didn't quite happen. So again, I don't want to focus here today completely on how not to execute mass timber. There is a good news story here, and that we were able to achieve it. And why I bring up these projects where it didn't happen is because that actually informed us not just on an education and a knowledge base, but actually on a network that was essential in ultimately realizing our first mass timber project, which we can see now in the next slide. So going in, sorry, just before the next slide, again, a lot of that work and collaboration that we did, studies in not just conventional models, as you can see on the right side, for multi-res development, but our work in the modular, volumetric modular, and then the work that I just discussed on the wooden office building project, that ultimately led us to the YWCA, or it's the local branch is YWICW Transitional Housing. And for this project, it was based on Rapid Housing Funding Initiative that had a very, very tight timeline, and also required some degree of modular construction, what they defined as modular construction. And although that does mean different things to different folks, it was ultimately defined through the program as having some level of offsite prefabrication that was assembled on site. So obviously that worked for us on this project. Again, in addition to the modular, the specific timing around the round 1 of the funding was actually a 12-month window for completion from the time of contract sign to actual occupancy, which for most of us, and I'm sure there's a lot of eye rolling on this call, especially with the knowledge base here in terms of the ability to get through approvals, through design, through tendering, through construction. That was a pretty monumental ask at the time, but through a very specific design build response, where we brought all of our trades, all of our consultants into the fold. We were also ready for it a little bit early because we knew of the program and some of the objectives of it. And so we were actually able to do this successfully on phase 1. And then, as I'm going to get to in some of our next steps and future directions, we've actually been able to utilize that same approach, that same team, and mass timber as our primary structural resource on rounds 2 and rounds 3 of the funding, round 3, which is active and currently on our plates right now. So again, when it comes to the fast track process and more importantly, the team, this is just a quick diagram that I want to walk through in terms of, the CMHC and that RHI funding, which you can see up in the top right corner, and knowing that was going to be coming down, knowing that we had that network of folks who were interested, who were tracking it, we ended up with Element 5 and on the back of the relationship we had on our wooden office building project, we started down conversations about how can we come up with a solution that will be suitable to the needs of these types of users, non-for-profits, supportive and affordable housing providers, and that would be efficient. And what kind of team would that look like? So from there, we ended up putting together that team. And as you can see, specifically on the right-hand side here, the trades and consultants were so critical to getting involved early. And then also ultimately, as you can see, the general contractor who we really needed. I mean, we as architects and holders of a certificate of practice cannot be constructors. So we knew that with the conventional CCDC 14 that a lot of these groups were going to be relying on for that turnkey approach and that fast track approach for the clients, that we would need a solid and reputable contractor to be able to take that on and take on that responsibility and work closely with. So we had worked on a number of projects with YWICW, and they became a really great partner along with ourselves, Element 5, and the rest of our trades and consultants to work that through. Another key part of this is, as you can see here, the CMHC funding came to in our two-tiered form of government, municipal government in Region Waterloo. That funding came directly to the region, and then the region actually administered that funding to YW. And on top of that, we had the city of Kitchener on the left, who actually offered up the land, which was underutilized vacant land, city-owned. So that in and of itself created a collaboration and an aligned motivation for everyone in the team, even at the approvals phase of the project, that really paid a lot of dividends in terms of that fast tracking process. And then, as is often the case, we also had a construction advisor, a consultant, client rep in Walter Fady, who was another local reputable multidisciplinary firm, who was again essentially part of the team and part of that collaborative effort that we worked on. So as you can see, the degree of collaboration and communication required through the project was extensive and ultimately led to a lot of our success. Here is something we created in the early stages of the project that just, again, was going to put that focus on what are the different stages and what are the different targets that we need to map out here and have everybody on the team understand. So obviously first was working through that planning and approvals process. In this case, and utilizing the mass timber, it was actually something that we needed to integrate not just the planning department, but actually the building department too, and getting their comfort. And in doing so, what we ended up doing is pulling on Vortex as our fire and building code consultant. We were able to not just utilize their knowledge and their understanding, but again, their network of other projects. So although this was one of the first multi-res fully mass timber projects constructed in the province and in the country that we're aware of, in this type of fast track approach specifically, there was some other projects, one particular in Toronto that Vortex had also worked for. So there was already a basis of understanding with the Toronto Building Department and an alternative solution that was provided to them. And we were able to, again, connect with them, start to open up that dialogue and exchange of information. And in fact, not just do it between us and our consultant and our design and client teams, but actually, we were actually able to connect the actual building departments and the chief building officials to start to foster that. And that's something that really helped us through that stage as well. And we've continued to utilize that in other jurisdictions, making those connections. Outside of that, you can see from our site approach and foundation design, it was very much based on a simplistic approach, as most of us know. If you start to get into very complicated underground parking structures and various things like that, you can really suck up a lot of the time of a project underground before you even get above. And so that was a bit of a challenge in terms of making sure the design was very efficient and streamlined from that standpoint. And then next we had, the superstructure, and that's, I think, where mass timber and that prefabrication, the precision of all the CNC and all those fastening and connection elements that Patrick went through really did pay off. And then obviously, the leadership of YWICW on the last few pages, 5 and 6, was also really important, and I'll get into a little bit of that here next. So I do want to show when it comes to that, particularly the superstructure and how that worked. And I think we do have a time lapse here of the building going up. So Patrick, I'm not sure if you want to flick that on or if that's going to work for us here.
So is that playing on your screen, Matt?
Not yet. but if not, we can
It's-
probably follow up with the link.
So it's not happening. We can skip that, Matt.
Okay, sure. Yeah, just to keep it going. The structure itself was erected in under 20 days. That view that we had and the time lapse video that we show was really interesting. And anecdotally, the principal in the school that the camera was mounted on was amazed. He felt like one day, you know, and there was nothing, and the next day it was a building. So that was no question a key part of the process. But another part, and as Patrick spoke to briefly, in terms of cost, that was another big factor, and it was in fact one of the reasons that we did go and decide to work with Malul Blamey and pull them on, was their understanding and knowledge of conventional forms of construction like this, where, you know, other non-combustible systems would have been used, particularly something like a precast or total precast building design. You know, that would have met the same intent as of prefabrication and modular in the definition. However, from a timing standpoint, you know, we were at the time, you were waiting 1 year in a queue to be able to get you know, the product, and for us, obviously on this project with the fast track nature, that wasn't going to work. So one of the big challenges, in addition to just understanding the cost and you know, is how do you do it in an apples to apples way, and that was something that we knew well through some of those other projects that I talked about, where we were comparing non-combustible and conventional building systems to CLT. It was always a challenge to wrap our heads around apples to apples cost comparisons. So what we decided to do is to specifically look at, in this case, precast or hollow core plank design, and our understanding and our knowledge of how to do that well and efficiently with optimal spanning ranges, with optimal panel thicknesses for shipping and installation and crane design and all of those factors. And we actually then incorporated that into our design of the mass timber and worked specifically with Element 5 and their engineering team on that. So as you can see here, what we were able to do through the design was come up with that a similar optimal length range of a panel. However, through Element 5 and their new manufacturing facility out of St. Thomas, we also understood that they could do up to a 3.5 meter or almost 12-foot wide panel. And of course, compared to that hollow core plank, which is always 4 feet, we immediately realized with about the same thickness of panel, we were able to do 3 times as wide, which there right off the bat, we just cut the number of picks off of a crane into site by a third. So we knew that from a speed standpoint and an efficiency standpoint, we were going to be picking up a lot of efficiencies there. Same too when it came on a 4-story building design, the max length of the panels, which is about 16 meters, actually allowed us to turn them the other way and run them full length for our elevator and stairwell cores. And still meet all the, you know, the building code definitions, but again, really try to wrench up that optimization and efficiency of things that way. One other thing from a design standpoint that really helped us was we had a site that was quite narrow, and we'll see in one of the pictures that I'll go through at the end, it had these sort of sharp points on it that really made it challenging to lay out a typical conventional building slab. So as we can see here, you know, typically in our multi-residential work and our conventional based work, we'd always be starting out with, you know, an 18-meter minimum width tower slab residential building footprint. But in this case, there was 2 factors. One, the site design necessitated that if we could narrow that building form, we'd actually be able to better utilize the site. But on top of that, we actually had client requirement that specifically wanted small 400 square foot or less units, 350 to 400 square foot. So by actually narrowing that building, we were also able to accommodate that programmatic need, keep the building area down, and yet still provide the really important 1-bedroom units they were looking for. So on those 1-bedroom units, because this specific project was tailored towards women battling homelessness, so it was a rewarding experience for, I think, all of us involved, because we were, you know, knew that the users of this building, and as is the case in a lot of different municipalities and jurisdictions with encampments and homelessness, you know, we were taking people who were specifically women in vulnerable situations, and they were coming and moving into these. And as you can see from our layout, with that narrowed building footprint, we were actually still able to create a bedroom with a closable door. And that was actually something in terms of, trauma and dealing with those sorts of things, that specific unit amenity was really important. In addition, we were still able to also accommodate barrier-free accessibility in our washrooms and movement through the kitchens as well. So a lot of those things were important programmatically for us. When it comes to, again, a big question is fire. We had a great fire and code consultant on the project in Vortex. The good thing, I think, from this standpoint, and we had known this from some of our previous experience, is there is a wealth of testing data that is available and understood and accepted. And as again, I won't speak to it in detail, but I think, and even some of the more recent changes to both the national and Ontario building codes, that is, it's starting to become even more incorporated into the codes themselves, and that referencing of CLT and mass timber is becoming more prolific. So that I think was just a matter of documenting. Again, there were some alternative solutions at the time of this project where we had to just make sure that referencing, the understanding of the testing and the certification standards for structure, delamination, fire performance, all of those things were properly understood, and there was a proper level of comfort there with the building department, and we were able to do that. Next, though, was the acoustics. And this was one that particularly, again, as there was a change to the building code from requiring STC ratings to ASTC ratings, that was a challenge that we did have to face. And unlike the fire issue we were talking about, where there's a wealth of data, it's more just a matter of pointing the building departments to that data. In this case, for the acoustics, there isn't a lot of data specifically around assemblies where exposure of the product, of the mass timber product is had. And so for us, particularly with that change in the designation of sound and acoustic performance, instead of having, just be able to cut through a wall and say, well, that's my assembly and it meets. In this case, we actually had to show that the entire room would perform. And when you had our goal of trying to expose as much of the surface of the product as we could to instill that sense of warmth and well-being and some of the biophilic advantages that come along with the product, it was really important to us to do that. So that's where, with our acoustical consultant, we had to get creative and frankly quite conservative on how we designed each unit to limit the spread of acoustic and sound from one unit to the other. And the way we were able to do that was to essentially checkerboard our unit finishes plan, where you either would get a exposed ceiling or an exposed wall. And that allowed us to, again, cut off sound on vertically across the transition of units and horizontally across the transition of units in a way that ultimately met the satisfaction of our acoustical consultant, who then provided our sign off with the city. It should be noted that since we've done this project and subsequent others, we've done testing on each of these. So we are actually now in a position to be building that knowledge of testing and performance, which is showing that we are actually performing better than expected and better than the conservative estimates, and therefore are excited and looking for more ways to pull some of this additional measures and expose more of the product, both for cost savings as well as, again, that sense of warmth and well-being. So you can see that there. Next, and another, again, area of concern for both clients and people and the team members that we talked about a lot was just the moisture control. And I think one of the big takeaways, knowing that this project was installed in September, and to my knowledge, that would have been September of 2020 or 2021, I guess. And it was one of the wettest Septembers on record, of course. So a few sleepless nights. But I think the great thing we brought on RDH as our building science and on-site consultant. So they had a lot of experience working both with mass timber and understanding, some of the challenges and problems that will come back, particularly after a building is enclosed and occupied. So we had their knowledge base, we had their understanding of when and how to be testing iteratively throughout the process. The great, again, knowledge base that we had through all of our detailed moisture control analysis was that the panels themselves, even in a horizontal application, performed extremely well. They are the glues and the edge gluing specifically, and the fact that there's such a strong focus in the plant for moisture control that once you get to site with a lot of the edge-gluing of the actual product, again, the water ingress doesn't really happen. And as long as you're not, you're having a process on site with your construction team to remove standing water, that's oftentimes heavily mitigated. There were some in the photo here where you can see the plywood splines that connect. That was an area that did cause some challenges throughout the construction, and to the extent that in some cases before we put roofing down in certain areas, we had to replace those plywood splines because, as we know, plywood really sops up water and it's very difficult to get it out. So I think from there, that's informed our process on subsequent projects where we've made sure to, as those plywood strips are going down, they're getting taped and sealed in a way that doesn't allow for that sort of water ingress over time. So finally, when it came to our envelope, there were different strategies on how we could approach this. There was a thought early with this clip system that Element 5 had come up with that could be a prefabricated, fully offsite assembled and installed on site wall system. Ultimately, we ended up not going with that, and we just had the actual exterior panels clipped on, and then we ended up doing a site applied thickened EIFS application with a 6-inch insulation. This was, again, very efficient from limiting the number of trades on site. So we were able to execute that very quickly and cost effectively. Moving forward, I mean, in our climate, I wouldn't say that for us, EIFS is always necessarily our preferred choice, but in this case, through some of the resilient, the low and high traffic coatings we were able to put on, and again, through working with our envelope consultant, working with DriveIt and their team, I think it ultimately was a very successful application and very high performing through the lack of thermal bridging and what have you. So again, here, I mean, when it comes to the BIM coordination and generally going back to some of those models and those collaboration models we talked about above, BIM coordination throughout the project was really essential, but ultimately it required that trade level involvement, not just in the design process, but even, on site in the trades. And you can see here, we have Kurt, our installer from Compact Framing, right on the truck. And a lot of us, we're out there more often than we typically would have been, which I think for myself and a lot of the group of folks in our office was a really exciting part of the process. To feel more integrated into the whole overall process was great. Here's a bit of an overall. You can see again the school and the public library in the background. You can also see that sort of nature of the site and the strange geometry of it. But again, it did really work well in an area that is heavily populated, lots of transit, and a really great use of some underutilized land in the city. Next slide. I'm just going to flick through some of the pictures here in the next couple minutes slowly. You can see, again, we did have the canopy where we exposed that product to create some warmth. The entrance, the columns themselves are at Douglas fir, but the CLT panel that you see there is the same CLT panel we used inside, actually the exact same dimension. We just pulled it out and used it there, that optimized 5-ply. So again, you can see the way that helps to just create that sense of warmth and well-being for a building that's otherwise, intended to be quite austere and not overly high end. That as a commentary too, I think, as our experience over, watching these CLT and mass timber projects come to life over the last number of decades, what we understood is that a lot of what we saw was high-end or high-profile institutional projects. And although those are great and exciting, one of the things for us in terms of trying to address the housing crisis and also trying to promote the more widespread use of the system and process for some of the, again, not just biophilic, not just environmental, but even efficiency benefits of the product, is we thought that if we can get and showcase how it can be used in an application like this, supportive housing, affordable, mid-rise, those are all challenging areas to deliver and typically not seen as utilizing high-end type of products. So we realized that if we had this opportunity, if we could execute it here, the ability to transition that back out to either market rate housing or office or institutional was going to be much, we thought, an easier process. And I think what we're seeing now in the marketplace 2 years after the occupancy of this project, that's really, starting to be the case. Case in point to that, as you can see on this site that we just looked at, that is the second phase, second building done through RHI round 2 that will have occupancy sometime in February. And this was taken back in the fall. So you can see that project also went up very quickly. That project was geared towards women and children. And again, maybe the testament, and without getting political at all, this was the announcement for the round 3 of funding, and through CMHC sort of coming out in the federal government stating that this is a program, and this housing initiative in the National Housing Strategy is at least on some levels working. And this announcement that was had with the Prime Minister and various other levels of government was actually broadcast from the lobby of that YW project. So that's, I think, a bit of an endorsement of the success that we had on this project. This is another project that actually was right on the heels of it, and that collaborative effort we talked about with the group in Toronto who had done a project and had the building department engaged. That was actually Our House Solutions. So they were working with the York region on a solution. We ended up in lockstep almost with our YW project, executing this slight variation. But I think this really goes to show the versatility and the adaptability and the efficiency of being able to repeat this model that we've come up with on this project, which was actually geared towards homeless men. Next slide. Here again, you can see the overhead view of both phases of that YW project that we looked at. Again, just a bit of a construction shot of the second phase of the project, and that allows you to see again that same envelope system, that thickened EIFS application that we used. Again, as the appropriate solution for this, and we're already looking at other cladding and building science envelope solutions on other projects as we carry on. Next, we could see we are seeing the proliferation of this system, and what this is a market rate project we're working on in Kitchener, where it was actually, interestingly enough, started down the path of a conventional. We do consider ourselves agnostic, that we can design with any structural system. This project was intended to be non-combustible, primarily utilizing precast, but through some of the costing and some of the market forces, got feedback from our builder team and our trade team that actually a hybrid approach with CLT floors and stick frame walls, as Patrick had talked about some of their work there, was actually the best way to go. And that's the way that this project is now going. So that's exciting. And this one, potentially more than any other, really is starting to showcase. This is a really exciting project, master planned block plan in Tillsonburg, which has a real close adjacency to the new Element 5 facility in St. Thomas. And this is a mixed use of buildings with mid-rise. You can see there is the high rise in the back, as well as that commercial office and retail in the front. So we're really able to flex our design muscles and really utilize and optimize this product on a project like this in a really versatile way, but yet in a way that takes this last, almost decade of experience and understanding, and, as I said, more importantly than anything, network of expertise, and applies it to projects like this. So, as you just finishing off here before I pass back to Patrick, for myself, I actually grew up in a rural area about an hour north of Kitchener, Waterloo, and this was actually a picture on the left that was taken from the erection of a family farm on actually the property I grew up on. And on reflection of our work over the last few years in this space, the picture on the right is on the site of building 1 of YW with the trade team and the constructors. A bunch of our team are pictured in this photo, myself with a little bit more hair. And, it just occurred to me that innovation, in order to execute on this type of innovation in the market, it is very challenging. But one of the things about being here today is reinforcing the importance of collaboration amongst not just design or consultants or constructors, but around everyone that's ultimately responsible for the execution of the project, right up to the approvals authorities, is so important. And for us, that's what we're really trying to push and promote in our industry right now. So thanks again for the opportunity. Looking forward to questions and having Patrick take over again.
Great, thank you, Matt. So challenges and opportunity. There are definitely challenges in the mass timber industry. There is the perception that wood burns, that it's not strong and that it won't last. There isn't a lot of experience in the industry. There aren't a lot of architects or engineers who know how to design and engineer buildings this way. There's not a lot of education in the marketplace. Human nature is we're resistant to change, we're risk averse. There's a lack of information. There are some challenges with building code, but Ontario has actually come a long way. We haven't mentioned it, but we can go up to a 12-story encapsulated mass timber building in Ontario at the moment. There has been some price volatility in the lumber industry over the last year, but at the moment, lumber prices are sort of rock bottom, which is great. There are barriers to entry for manufacturers to get into this industry because it's a significant investment to get a plant up and running. Profitability is quite slim. The margins aren't high at the moment. And also it's a risky and complex industry. But I think the construction industry is also facing many challenges, maybe even more so than the mass timber industry. For years, there have been thinning margins, labor shortages, abysmal productivity. You mix that with the challenge to house and provide infrastructure for a growing population, which is largely going to happen in urban centers. In the midst of an environmental crisis that's exacerbated by the way we build today. So we need to change the way we're building in order to have less impact on the environment. There are signals of large-scale disruption that are happening in the industry at the moment. We're seeing the introduction of environmentally friendly alternatives to concrete and steel. We're seeing more mass timber manufacturers coming into the marketplace. There are advances in modular construction, advances in software technology, so 3D modeling and BIM technology, and then a lot more access to mainstream capital. RBC Capital Markets predicts that there is a compound average growth rate in mass timber at about 17% per year. Based on our experience, we're seeing that growth rate is significantly higher than that, so we think that's quite conservative. There's a growing number of resources that are available in the marketplace. And, there is one major mass timber manufacturer in Ontario at the moment, which is Element 5. But many of the buildings, the larger buildings that I showed you at the beginning of the presentation, were supplied by mass timber manufacturers either outside of Ontario, other provinces, or by Europeans. So there's certainly a supply of mass timber manufacturers. The photograph that you see on the left is of our plant in St. Thomas. It's quite large, 137,000 square feet. The next photo is the interior of that. It is considered the most fully automated mass timber manufacturing plant in North America at the moment. We have the capacity to produce about 80 of the YWCA buildings that Matt referred to in his presentation. That is assuming we did only those buildings through the course of the year. And we control our supply chain right from forest floor through to finished product. And all of the products we source come from Ontario FSC certified forests. So Matt, let me turn it back over to you. Your one slide introduction to Element 2 for Edge Architects.
Yeah, thanks. So I think, I gave probably a bit of the overview of some of our work here that you can see. And again, going back, in terms of the sustainability, the innovation and the collaboration, those are really driving forces for us. And trying to figure out, we understand why convention is the way it is in construction. It's, we're talking about big projects, big investment for everyone involved. So trying to figure out ways to do things differently is a challenging thing. And that's where we feel as though we're well equipped to try to do that. And part of doing that means really understanding the conventional means and being well versed and well experienced in those, which we are or feel we are. And that gives us an ability to understand where the opportunities actually lie. So you don't find us always trying to push, our innovative things. We are always doing it in a way that actually makes sense, where there can be an advantage that isn't just aesthetic or isn't just environmental, because we believe that if you're looking at that through that myopic lens, it's not going to be effective in terms of the execution, and that's where we ultimately want to live. So I'll leave it there. There's a lot of really interesting. I've just started scanning the Q&A, and I think there's a lot of interesting questions there. Some of them, hopefully, we can answer a lot of them today. I'm sure there'll be lots of discussions afterwards, and I think both Patrick and I are excited to connect with all the interested parties here and keep building on that open source collaboration in the industry.
So,
I just wanted to point out that there is access to other resources, and that is Ontario Woodworks, for example. I don't know if you're familiar with them, but they have lots of free technical resources around the wood industry and mass timber, and a number of courses as well. So with that, I will turn it back. I'll stop sharing and I'll turn it back over to Giovanni.
So I think that just by the questions alone that we've had, we can do another webinar. The questions are fast and furious and excellent at that. I'm just going to touch upon a couple of them here. If we do not get to your question, do not worry. I'll have Patrick and Matt respond to them, and we can actually have like a question answer distribution after the fact. So one of the questions that is asked is, on the Ascent project, has the first 8 floors in concrete and then wood. Why is that? Why is the mixed use? Is it aesthetic or is it structural in nature?
I would say it's largely structure in nature. The 25-story building. We weren't involved. It wasn't our project, so I mean I can't attest to the reasons for that. But I would assume it's more of a structural nature. It might have something to do with code compliance as well. Matt, I don't know if you have anything to add.
No, I think just a general comment that actually I think already applies to a lot of this, and something that we're doing. Again, we would have seen, you know, that mass timber was always something that was high end or seen for a certain type of thing. And what we've tried to realize is that as creative designers and working with design teams of structural engineers and fire consultants and all these sorts of things, it's always about optimizing any structural system appropriately for the best use. And that means being open to using any product in any way, and also looking for hybrid uses. And that's where we're seeing, you know, on a project like that, again, I don't know the inner workings of it, but that, you know, I'm assuming that there was some sort of both code or structural efficiency related reason for that. And that's what we're seeing is, you know, always just searching for the best possible solution and using the innovative product in this case, or innovative design feature in a way that makes sense and actually helps contribute in a valuable way.
So I have a question about basically a comparative between obviously mass timber and steel and concrete construction. Is there a sweet spot where the pricing level on the larger buildings then tips in the scale for mass timber being more beneficial or more cost effective, that is?
Yeah, I'll touch upon that. Maybe Matt, you can add some value to that as well. But so we're seeing a lot of opportunity we're seeing opportunity across the industry, from everything from single family homes up to large commercial buildings. It's probably easier to talk about where we're not seeing mass timber, and that is anything above 12 stories right now. As I say, we can go to 12 stories in Ontario, but we're not seeing mass timber, at least at this point, you know, buildings beyond 12 stories. We're not seeing mass timber in sort of the industrial building typology that is really well served by off-the-shelf sort of steel buildings. So where there's long spans between support structures. So those are sort of the two key kind of areas where we're not seeing it at the moment. The sweet spot where we have identified is really that 2 to 6 story range. And so that's why we've proactively gone after the multi-unit residential building, because you know, that mid-rise section of the marketplace, because the lower end of the industry is well served by the lightwood frame industry. The upper end above 12 stories is well served by the concrete and steel industries. And there's that missing middle sector of the marketplace that is really well served by the mass timber industry, and where we know we can be cost competitive.
On the oh, go ahead, Matt.
So I just say I totally agree that, and even though as a focus of our work, being focused on the missing middle, you know, as it's been coined, that is exactly where mass timber is providing all its efficiency. Thick frame, oftentimes you start to struggle with on those higher scale, you know, 2, 3, 4 stories, or any mix of uses where things are coming together. On the fire side, that becomes challenging and complex. Mass timber is a great solution to that. But then also in an efficiency standpoint, if you can design it efficiently, it can come in where precast and steel and other hybrid types non-combustibles struggle with the economy of scale projects that are smaller. That's where we're seeing a lot of value.
So we have so many good questions here. Holy smokes. So on mass timber structures, what would be the durability or the lifespan of the structure as compared to concrete and steel structures?
I love that question. So, Toronto has this really rich history in heavy timber construction. So there was a period of time, sorry, there was a period of time between the 1850s and the 1920s that there was a lot of these brick and beam buildings constructed in the Ontario marketplace. And there's about 150 of those old brick and beam buildings that are still around today in Toronto, some of which have been around for 150 years or more. So one of the preconceived perceptions that we have to overcome in mass timber is that it's not strong and it won't last. But as evidenced from what's happened in the brick and beam industry from way back when, these buildings last for a long time. Like the YW project that we did together with Matt, we're anticipating conservatively that the life expectancy for that building will be 100 years or more.
Interesting.
Yeah.
Okay, so in regards to longevity of it and and whatnot, I think we also want to look at historical data on water claims. Does water damage impact the life expectancy differently than it would on steel and concrete? And again, then we have the added caveat of mold. So who wants to take
Matt,
that
do you
one?
want to?
Sure. Yeah, I mean, I think what we're understanding and seeing proven out is that all buildings, I mean, moisture control with any system, but particularly anything where you have, like concrete buildings or anything with concrete toppings, in terms of conventional non-combustibles, the moisture control there is also, something that needs to be dealt with during construction. And so that system in place, needs to be there regardless. In terms of once the building is enclosed and the building has climatized fully, there's really, I mean, they're really the same. A structure is a structure is a structure, regardless of what type of system or hybridized system it is. So that I think we're understanding are quite static. Of course, as soon as you get into either fire or water damage during construction or fire or water damage after construction, any structural system is going to have a wealth of analysis. Oftentimes, as we know, it's not so much in fire events the fire itself that creates challenges for the building and the structure, but actually the water and the sprinkler, which of course is a great thing for life safety. But in terms of building durability, that can be a challenge. So again, I'm sure we're going to get to it, but the insurance industry and their understanding of this type of product and building and ability to cover it is something that is with the more buildings we do, the better that process is going to get. But generally, for us, as a product, it's largely the same type of factors influencing all systems.
So I did note during your presentation that you talked about sealing joints and whatnot, just like in a typical construction that would be the case. So I just think that it's just a different process that you would go about doing so. I think one of the mainstays or main questions that we've had repetitively is in regards to fire safety and when the building models are being built. I know that there was some fire testing that occurred in Ottawa on mass timber structures and whatnot, and I do know that ultimately the study is pending when it comes down to the results of which. But what can you touch upon in regards to fire safety and obviously the insurance portion of that, and how we can view mass timber with regards to fire and insurance?
Matt, do you want to talk about that one?
Sure. Yeah, sorry, I just cut out there. Giovanni, can you just...
We can hear you. Can you hear me? It's basically the question was in regards to fire safety and insurance component of it, and how the two how do we bridge this and moving forward on mass timber projects?
Yeah, as I said, I think the industry right now, in terms of the expertise in the fire consulting, and actually the code changes that have happened in the last, I would say, the most recent one specifically, the Patrick reference that allows for up to 12-story encapsulated, have really created a large runway for the acceptance through the building code of mass timber projects, and does acknowledge the wealth of testing data that's out there that clearly proves out the performance of the mass timber is very much like concrete and a lot of other systems. The char rating, the ability of that fire to not just completely burn through the structure, as long as you basically get your char rating and you get your, you just have to design the panels to be able to char, and then have, if they're exposed, and then have structure left after the charring has happened and the fire is sequestered. So that piece of the call it the building science is very well known, very well understood, and very well accepted from the code standpoint. And again, I think as more buildings get done, that the insurance will catch up to that.
Right. So is there a group trying to modify the building code to have it widely accepted across the province or the country, especially in regards to fire protection?
Yeah, I mean, I don't know. I mean, Wood Council, a lot of these other, groups out there are doing a lot of good work, and I think there has been a lot of that happening actually already. I'm sure it's going to continue. And like I said, we're seeing that with every iteration of the code that's come out for the past decade. There has been that push to be more permissive of wood and get back to the comfort that we had, as Patrick said, 100 years ago.
I'll just
So
talk briefly about insurance. Yeah,
Yes.
so when mass timber came out to market, and the whole industry struggled with misperceptions about building with wood, and I think the insurance industry struggled with it as well. I don't know if they just didn't have a thorough understanding of it, or whether they were looking for an opportunity to charge more for this new kind of building typology. But there has been more maturity in the insurance industry about dealing with mass timber. You may find, if you went out to the common suppliers in the industry for insurance, that their rates are significantly higher than others. But there are a select group of insurance companies that taken a leadership role here to really dive into it and understand it better and understand the risks. I think there may be some people in the audience here from the insurance industry. And so insurance rates have come down significantly for mass timber projects.
So I do know we're at the hour, but there's so many questions. If everyone doesn't mind, I'd like to just ask one or two more. We've got a contractor who is asking if there is the possibility of bringing an affordable housing system to market. Can we share some high level structure only costs with developers? Is that a possibility that we can then entice developers in order to accept and move towards mass timber?
Absolutely. Maybe I'll address that first, and maybe Matt, you can jump in as well. But we have this wonderful fabrication facility in St. Thomas, Ontario, and the reason why we have it is we're motivated for many reasons. So it's a great business opportunity, but we're also in a position to make a positive contribution to the environment. But we also see that it's our responsibility to make a positive contribution to affordable housing for First Nations communities, to create healthier schools for individuals. So Matt and I actually set out about 2 years ago to design and engineer a mass timber building. One, we saw a great opportunity, that mid-rise section of the marketplace, but it was also an opportunity for us to make a positive contribution. And since then, we've been pushing hard to offer the industry a sustainable and affordable mass timber solution for the affordable housing sector. And so we won our first project together with Matt. We've since done a second project with Matt for the second building that he showed you. We did the third building, which was the hybrid structure with CLT floors and lightwood frame walls. And now we have a whole push to go out to all the municipal governments, to Toronto Housing Secretariat, to Toronto Housing Toronto Housing Secretariat, to promote our affordable housing solutions. So yes, we're really interested in that sector of the marketplace, and any general contractor who's interested in working with us, please contact us, and we can provide all of the information that you need to help move forward in that sector.
Yeah, I think that obviously the majority of questions are about the financial aspect, about, if we want to sell mass timber, or if we want to make mass timber a alternative that everyone jumps upon, it has to be a price point discussion.
Absolutely.
I'm also finding out that, I'm going to ask just the last question here, but are you finding that builders risk and wrap up insurance is higher for mass timber structures than steel and concrete structures?
It's not my area of expertise, quite honestly. I haven't had to deal with that personally. Let's just say I've not had it raised as an issue when we are presenting pricing for mass timber versus other forms of construction. We haven't seen pushback from the general contractor sector that tells us that is the reason why projects aren't going ahead, is because it's proven to be more expensive. That's really all I can tell you about that.
Yeah, and just to second that, I think, you know, in our that's not our area of expertise either. But I'm actually going on to another call after this about another mass timber project with, again, a reputable builder here. So I can definitely ask it if there is a follow up, and I'd be happy to go through the list of questions here and help consolidate a list of Q&A responses. We can definitely look to get some of that information and the expertise on that particular item if need be. And to Patrick's point as well, for us, as from the design optimization side, trying to get these systems with apples to apples comparisons has been so key. So for us, the metrics are clear: is what does a total precast building on a per square foot typically go for? We are using and working with contractors who actually know that, who have clear and current data on that, so that we need to make sure, and when we're in these competitive and RFP environments with them as team members and leading the proposals, the mass timber that comes in, that pricing has to be in alignment so that we can be competitive. And I think so far we're showing that we've been able to do that. But it does take, I think, a design team and a design-led, design-build approach that really looks for the optimization of the system to the benefit of the project. And that's where we put a lot of stress and frankly value on our input comes in.
So I want to thank you both for participating. Patrick, Matt, the conversation was fantastic. For all those who've asked questions, I am going to pass along all those questions to both Patrick and Matt to address, and then we'll put it out as a follow-up, including the presentation itself. I think there's a lot of excellent data within the presentation. You have resources within it as well. If you need to reach out to either Patrick or Matt, there are at a phone call or an email away. Any last words, gentlemen? Patrick, I'll flip it to you first.
Well, I think there's a great opportunity for general contractors in the industry. We're seeing huge demand for this. It's an innovative approach. And I think there's an opportunity for anyone that wants to take, an early entry, take a leadership role, because we know that the companies who have invested in it so far, they seem to be getting more and more of the same projects over and over again. So they become the go-to organizations in the industry. So I think there's a great opportunity for general contractors.
Matt, you get the last word.
41 years old, and I really hope that no one went over that. I know I got some gray here, but otherwise I think I'm doing okay. So no, thanks again, everyone, and yeah, looking forward to next time.
Fantastic. Once again, well, finish off. Happy birthday, Matt. To all those again participating, the recording will be available in short order. We'll link it to our website and send it out to everyone who participated today. Thank you one and all for your participation, and we look forward to our next webinar, which will be happening on February 25th, and all about cybersecurity. So with that being said, thank you everyone for participation. Have yourselves a fantastic day.